Hello and welcome back to my channel. My name is Konstantin and today we're going to solve one of the most famous problems out there, probably the most famous of them all, reverse linked list. Given the head of a single linked list, reverse the list and return the reverse list. How are we going to do this problem? Probably the simplest way is just to throw everything in an array and just reverse the array and create the linked list from the array. But I strongly believe that if an interviewer will give you this problem in an interview, you're lucky enough to have it, since it's considered an easy problem. He wants you to deal with pointers, so he doesn't want you to use an array or extra space. So the challenge here is that by giving the head of a single linked list, we have access only to this pointer. So we do not know what's after and we do not know what's before this pointer. So if we move to 2, we don't know what was before, or 3. So that's the challenging part in this problem. How can we reverse this if we don't know what's before or after? Let's jump into our whiteboard and I'll show you how we can do this super easy. And once you see it, you'll remember it for life. Even 20 years later, you'll still remember this problem. So let's go to our whiteboard right here. This is our linked list, right? So what you have to keep in mind is, even if we don't see it here, we can imagine that we have a null node right here and a null node right here. These are null nodes. So this null node points to 1 and this points to null again. This is very important just because it kind of like makes us visualize the big thing. We know what's before and after. And the second hint, or the second trick that I want you to think about is, when I firstly saw this problem a while ago, I was imagining that like my result will look something like this: 5, 4, 3, 2, 1. And while this is correct, is also not super correct, and it kind of like gives you more headache. I think you need to imagine your result as, like, visualize your result as looking exactly like this. The only thing that the arrows are pointing the other way. So if you see that, this to me was like much easier to visualize it, like, oh, I'm not gonna bring this node here and so on. So this is kind of like how your final result should look like. So now let's see how we can solve this problem in place. How can we reverse this linked list in place? So think about, this is what's given to us, right? This is the head, right? And we know that we have a node before. So we can call this node previous, right? Is before 1, so therefore is previous. So right now, imagine we only have these 2 nodes right here, or these 3 nodes. Disregard this part. We know that if we just need to change the arrows, right? If this is 1 and this is previous right here, right now we know that this 1 needs to point to this previous right here, right? So how are we going to do that? So the way we're going to do this is by simply cutting this link right here. We want to cut this link right here. So we want to cut this link right here, and we want to point this, as I said, to previous. But if we do that, can we access this node right here? The answer is no. This node right here and all this part right here is lost forever. So just before we cutting this link, we know that we need to get a hold of this node. So we'll create a node, and we need to know this node. We need to store it into a temp or whatever you want it, but you need to store this node, and then you cut the link right here. So let's assume that our first step is get the next node, right? That's our first step. So get next node. The second step is to point our current node to the previous, right? So point our current to the previous one, right? And then all we have to do, after we've done that, all we have to do is move this previous one over to the right and move this current right here one over to the right. So do you see what we're doing right here? So we're moving, so step 3 and 4 is move our previous to the right, towards the right, and move our current towards the right. So all we do now this is going to be our previous, this is going to be our current. Now again, we're storing this node right here in the next or temp. We're cutting this link, we're pointing this to the previous, which was this one, and then we're moving them again. Now this becomes our previous, and then this becomes our current. And then again, we're storing this one. As we said, we're cutting this link right here, we're pointing this to this one, and then we're doing so on and so on until we reach the end. And at the end, all we have to do, this previous, this current, it will point out to this null right here, and this previous, right, since it's one before that, it will point out to this. So we'll just return our previous, and then all the arrows will be on the other way. So let's go ahead. There are only 5 or 6 lines of code. It's very easy. I think once you've seen this, you will remember this problem forever and always. So let's go ahead and let's create a node first, as we said. So list node previous and is equal to null is just before, right? And then we're doing this processing while our head is not equal to null. And what we said we're gonna do, we're just gonna create a list node. We're gonna call it temp or next, or I'm just gonna call it next right here, next node, and it's gonna be equal to head.next, right? So it's the next node from the current position where I am. If this is my current position, next node, it will be the next node. And then my head.next is equal to previous, right? Right now I'm at the point where head.next, I'm cutting this link and I'm linking it to the one before that. And then my previous is going to be equal to head, and head is going to be equal to next node. So what we did right now is we just moved both of the nodes, previous and current, we moved them one over. And at the end, we said all we have to do is just return previous. And then that's it for this problem. I hope you will remember this problem. I came back to this problem a lot of times just because I couldn't understand completely why they're doing it the way they're doing it. But I think now you're gonna remember this problem forever, and it's gonna stick with you for the next 20 or 40 years, or how many years you would want. Thank you for watching, and I'll see you in the next video. Please consider liking this video if you think you're gonna remember this problem in the next 20 years.